Hey guys, in this video I'm going to go through two examples of composite function questions where we need to find the domain and the range and also check whether the composite function exists or not. And I'll show you what to do if it doesn't. Now this topic confuses many students, especially when it comes to restricting the domain to make a composite function exist. If you haven't already, I strongly suggest to watch my other video called Everything You Need to Know About Composite Functions in 8 minutes. In that video, I'll go through the theory part and explain the exact steps you need to follow to answer composite function questions. I'll add a link to the video in this post, so do check it out if you haven't seen it yet. It'll help you better understand this question as well. Alright, let's jump into it. Let g of x equals x squared for each of the following functions f, find the rule of f of g of x, and find the range of y equals f of g of x, and state the maximal domain for the composite function to exist. Part A. F of x equals minus 2 e to the x minus 1. Part 1. Find the rule of f of g of x. And so f of g of x is going to be f of x squared. And so for the function f of x, we replace x with x squared. And so this is just going to be minus 2 times e to the x squared minus 1. Part 2. Reading the question, we can't assume that the composite function already exists. And so before trying to find the range in the domain, we need to construct a table of domain and ranges, and write down the domain and range of each of the functions. To do this, you should always sketch the two functions. F of x is an exponential function that's reflected in the x-axis and then translated one unit down. And g of x is just a basic parabola. Now we haven't been given any restrictions on the domains, and so we need to write the maximal domains of f of x and g of x. The domain of f of x is going to be all real numbers, and the range is going to be from minus infinity to minus 1. The domain of g of x is also going to be all real numbers, and its range is going to be from 0, where 0 is inclusive, to infinity. For f of g of x to exist, then the range of the inner function g of x has to equal or be a subset of the domain of the outer function f of x. And so looking at the table, we can see that the range from 0 to infinity is a subset of all real numbers. And so f of g of x does exist. And when a composite function exists, meaning it's defined, then its domain is going to be the domain of the inner function. And so the domain of f of g of x is going to be the domain of g of x, which is all real numbers. To find the range of f of g of x, we would normally sketch its graph and then read off the range. Now looking at the rule of f of g of x, we haven't been taught how to sketch the graph of minus 2 times e to the x squared minus 1. And so we need to use the second method of finding the range of this composite function. Again, this is explained in detail in my other video. In short, to find the range of f of g of x, we just sketch the graph of its outer function, which is going to be f of x, only this time we restrict its domain to be the range of the inner function, which is going to be g of x. And so sketching the graph of f of x, with its restricted domain being from 0 to infinity, we're going to get this graph. And so the range of this graph is going to be the range of f of g of x. The range of this graph is from minus infinity to minus 3, where minus 3 is inclusive. And so the range of f of g of x is going to be from minus infinity to minus 3, where minus 3 is inclusive. Part B. F of x equals log e x minus 1. Part 1. F of g of x is going to be f of x squared. F of x squared is going to be log e of x squared minus 1. Part 2. Just like before, we need to construct a domain and ranges table and fill in the rows. From part A, we already know that g of x is a basic parabola with a domain r and the range from 0 to infinity. Sketching the graph of f of x, this is going to be a log function translated one unit to the right. Its domain is going to be from 1 to infinity, and its range is going to be all real numbers. And the domain for g of x is all real numbers, its range is from 0 to infinity. For f of g of x to exist, then the range of the inner function g of x has to equal or be a subset of the domain of the outer function. Looking at the table, we can see that the range from 0 to infinity is not a subset of the domain from 1 to infinity. And so f of g of x does not exist. In other words, it's not defined. And so to make f of g of x defined, what we need to do is restrict the domain of g of x so its range will equal from 1 to infinity. If we restrict the domain of g of x to be from minus infinity to minus 1, and then from 1 to infinity, where minus 1 and 1 is not included, then the range of this function is going to be from 1 to infinity. Another way we can write this domain is to say all real numbers except for the x values from minus 1 to 1. From here, what we need to do is define a new function. We can call this new function anything, but some textbooks call this g star of x. And so, entering this into a table with another row, we can call this g star of x. And the domain of this function is going to be all real numbers except for the x values from minus 1 to 1. And its range we know is going to be from 1 to infinity, which is now going to make the composite function f of g star of x to exist. And so the domain of this composite function f of g star of x is going to be the domain of the inner function. And the domain of the inner function is all real numbers except for x values from minus 1 to 1. To find the range, we would need to sketch the graph of f of g star of x. But again, we haven't been taught how to sketch log e x squared minus 1. And so using the second method to find the range, we need to sketch the graph of the outer function f of x, only this time we're going to restrict its domain to be the range of g star of x, which is from 1 to infinity. And so sketching f of x with its domain to be from 1 to infinity, this actually doesn't change the graph. And so the range of this function with this new domain is going to be the range of the composite function. And so the range is going to be all real numbers. And so the range of f of g star of x is going to be all real numbers. And that's it for this question. If you found it helpful, then share this video with your friends. Now that you know how to answer this question, you can also try to do the 2017 Exam 1 Question 7. To check out the solution, you can go to the Maths Methods Club, and from the year drop-down menu, select 2017. And then from the question number, select question 7. Try this question and see how you go. Good luck, and I'll see you guys in the next video.